Hi everybody, welcome. It's Jim Corkins. We are continuing on with our course. So if you haven't done so, please do the reading. Now, before we start on 2D Coulomb forces, or creating 2D Coulomb force equations, please watch the two videos of 1.2 review in trigonometry and also 2D vector addition. Those two videos will help you out. It's going to make you much more successful in the course in general, and it's going to set you up for what we're going to do. So if you're watching this video now, stop and go watch those two videos and take notes and then come back. All right? This video is also going to be the examples for our 1.2 tutorial, which is Coulomb Forces in 2D. So let's get started. So in these tutorials, you're supposed to sum the forces in the X and Y direction on the black charge, in this case the C charge, which is the -3Q charge. So we're going to define all the horizontal and vertical force equations on the -3Q charge in terms of K, Q, and L. And also, I just want to make sure that you are going to be doing good trigonometry, so I want you to indicate what angle you use here. You don't have to use my angle, like if you watch those two videos on 2D vector addition and the review of trigonometry, you could use different angles, right? So if you use 30 degrees for my angle, well, you could also use 60 degrees, and you would instead be doing sine of 30 degrees, you'd be doing cosine of 60 degrees. So you don't have to use my angle, but your answers will be the same as mine for the X direction and Y direction. So let's go ahead and get started. So the first thing that we're going to do is we're going to start off with our force diagram on the -3Q charge. So I'm going to write my coordinate system just like I did in the 1D. So nothing has changed as far as the procedure that I've been trying to teach you. Okay, we're going to write our little coordinate system. And in fact, since I have this area right here, I'm going to actually put the coordinate system right on top of this -3Q charge. It'll be a lot easier for me. So I'm actually going to write it right here. Okay, now that I have that, I'm going to label this as positive X, negative X, negative Y, and positive Y. So I think this is going to help make more sense when we're doing these tutorials. All right, you have a red positive 2Q that's up here. Now it's going to be pulling our -1Q up towards it. So I'm going to write that vector just like I did before. The problem with this is, well, you'll see. We're going to have to do some labeling. So we do know this force vector is going to be the force, and it's pulling it up and to the right. So we don't know if that's positive. I mean, it's pulling it up and to the left. So it's pulling it in the positive Y direction, but it's also pulling it in the negative X direction. So since this is a diagonal, it technically does not have a direction in front since it's not adhering to our coordinate system. So we know this is a 2Q force acting on it, and we need to figure out its distance away. All right, well, to figure out that distance away, that distance, and I'm going to just use a black line to help me. That distance is this black distance right here. Okay, so this dotted line distance. And the problem with that, and these should be right on top of each other, but is we don't know what that distance is. We have to figure it out. Well, this is where your trigonometry is going to come into play. This distance, this is your c squared, right? And so off to the side, this distance is c, so that's your c squared, and that's going to be equal to L squared plus 3L that you're squaring. So that distance, which is c, that's going to be that distance. Okay, so we're going to multiply this out. So this is going to be L squared plus 9L squared. So that is going to be equal to 10L squared. So square rooting both sides, this is going to be L square root of 10. So now we know the distance from the positive 2q to the negative 3q as L square root of 10. Okay? Now we have a problem. We need to get this diagonal. Okay? So this hypotenuse, just like in the addition of vectors in 2D, and also the trigonometry review, this diagonal is the product of two vectors that are adhering to our coordinate system. So starting from the beginning, this first vector, which that is horrible looking, right here, it's going to be this long, pointed to the left. Okay, so if this vector right here is the addition of, is pointing up and to the left. So I'm going to, starting from here, I'm going to go to the left first, and I'm going to go up here to the top. So add those two vectors together. You started here, you walked to the left, you then walked up, you ended here. So starting from this overall force vector starts from here to the end, and that's our overall force vector. Now, we need to establish a diagonal. So since I've made my triangle around this area, theta, I'm going to choose theta to be right here. Okay? I could have done this. Oops. I could have done this, and then our theta would be right here. But I want to do this way, so I just chose it. Okay? Now, this is the hypotenuse. And we have this angle as pointing in the x direction, and we have theta right here. Okay? First of all, we don't know what theta is. We need to figure that out. But we also need to label this in terms of the hypotenuse and theta. So let's do that right now. This vector, this horizontal vector, is pointing to the left, and it's going to be f positive 2q, so it's going to be hypotenuse, comma, L square root of 10, and this side is physically touching theta, okay? And so that's going to be the cosine of theta. And how I got that is off the side, I'm going to say this. You have sine of theta, which is going to be equal to opposite over hypotenuse. And then, so when we multiply both sides by the hypotenuse, you get h sine of theta, which is the opposite side. Well, this is the opposite side to theta. Cosine of theta is the adjacent side, which is adjacent to the angle over the hypotenuse. Well, multiply both sides by the hypotenuse, which is f2ql square root of 10, that's the hypotenuse, and this is the adjacent side. So right here, this is the adjacent side, right there, since the adjacent side always physically touches your angle theta. Okay? Now for this opposite side here, we said it's going to be the hypotenuse sine of theta. Hypotenuse sine of theta. Well, here's our hypotenuse, so this is pointed up. And it's going to be the hypotenuse, which is going to be the positive 2q, comma, L square root of 10. And this is going to be the sine of theta. Right? So this is our opposite side. Okay? Again, if you had a hard time with this, please watch those two videos on reviewing trigonometry and also addition of vectors. It will help you out. Okay, now the last thing that we have to do is we need to figure out what theta is. Well, theta is right here, and we can figure it out using distances. Theta is opposite L and adjacent to 3L. Well, when I hear opposite over adjacent, I think of tangent. Tangent of theta. That's going to be equal to opposite over adjacent, where in this case, tangent of theta is going to be equal to the opposite of this. Theta is L over 3L. In other words, since those L's cancel out, that's 1/3. So, since we have tangent, and this is 1/3, the inverse tangent of both sides is going to be the inverse tangent of 1/3, or the arc tangent. You could call it that too. All right. So I'm going to take 1 divided by 3 equals, go to trigonometry, second function, and take the inverse tangent of that. So that's 18.43. So theta is 18.43. Well, now I'm going to replace those two thetas. I'm going to write 18.43. 18.43. Okay. So our angle that I'm using is 18.43. If you used this as your angle right here, that would be 90 minus 18.43. So 90 minus 18.43, which would be 71.57. So you could have either of these, 71.57. Either one of those is correct. Okay. Now, just like in the 1.1 tutorial, we just want to sum the forces in the x direction and the y direction. We don't need to do much else. Okay? And so what we're going to do is, you know what, I'm going to clean this up a little bit. I'll write this a little bit over, give myself some room. Okay. Let's sum the forces in, well, the one force in the x direction, right? And it's going to be this one. So just for right now, I'm going to follow the procedure that I taught you guys. So this is going to be positive 2q. It's pointing to the left, comma, square root of 10. And I'm just going to write cosine of 18.43. So now when I write out this equation, We're doing a force diagram on our negative 3Q charge. It's due to the electric field of the positive 2Q charge. That is a distance L square root of 10 that we're going to square away. And there we go. And then cosine of 18.43. So multiplying this all out, we have our negative in the front. I'm going to keep it in red. So negative in the front. This is negative 3Q. So this is just 3Q times K times 2Q. So that's going to be 6KQ squared all over 10L squared times the cosine of 18.43. So multiplying this all out, all right, so whatever the cosine of 18.43 is, let's find out. 18.43, take the cosine of that and multiply that by 0.6, which is 0.569. So 0.569. KQ squared over L squared, right? So I did cosine of 18.43 times 6 divided by 10, which is 0.6. And there should be a negative in there. Four, 3 equals negative. So in other words, I'm going to round this, and I want you to round your answers. So to the nearest tenth. So this is going to be negative 0.6 KQ squared over L squared. So your answer for the x direction is negative 0.6. Okay? For the y direction, we are going to be doing the same thing. And the great part about doing this, see the hypotenuse for the y direction? It is the same as the hypotenuse for the x direction. So the great part is we could actually just go right to this, and instead in our y direction it's going upwards, right? So it's going upwards, but it's the same hypotenuse, which is going to be 6/10 KQ squared over L squared, right? And instead of cosine of 18.3, it's going to be sine of 18.43. So I don't want you to go through all of this again for the y direction. You've already done it, so just go right to it. So the hypotenuse is this part, which is here. You just got to be careful about this vector is pointing up, not down. So, and then now we could go ahead and just put this right in. So 18.43, I'm going to take the sine of that. I'm going to multiply that by 0.6 equals 0.189. So this is going to be positive 0.189 KQ squared over L squared So this is going to be positive 0.2 kq squared over L squared. So positive 0.2. Okay. So hopefully this is setting you up and this is going to help you with your tutorials. Okay. So this is the basics of it. I demonstrated it as the procedure as efficiently as I could. Let's do another one where you have now two objects acting on your negative 3q. You still have your positive 2q acting on our negative 3q, but over in this corner, we have a negative 1q acting on it. So let's see how this changes some things. All right. So just like we did before, we're going to start with our force diagram. Okay. In fact, let's go ahead and go here. All right. Label it positive x, negative x, positive y, negative y. Okay, here we go. Let's try it out. So again, we're going to have our positive 2q acting on our negative 3q charge, pulling it up towards it. And this was F positive 2q. And we'd already worked out that that was L square root of 10. So basically all of this is the same as it was before, right? So I'm going to just use my answers for that part. So positive 2q L square root of 10, and we found out that this was 18.43. So this is going to be the cosine of 18.43. And that should be negative. Now the upwards vector is going to be the sine of 18.43. So that's pointing up. So that's going to be positive. The hypotenuse, which is the same hypotenuse, comma, L square root of 10. And this is going to be the sine of 18.43. Okay? So we're going to have a situation where, oops, I'm just having you note this. I'm not going to grade it, or I'm not going to grade your angles to see if they're the same or different from mine. So I'm just getting you to officially note those angles, any angles that you've used. All right. Now, this negative q charge, negative 1q charge, is going to repel our negative 3q charge to the right. So I'm going to write a nice long vector. It's pointed to the right. And that's a negative 1q charge. And it's a distance 3L away. Okay, that is our force diagram. Again, I used our work over here, L square root of 10, and that 18.43 right here from that. Okay, now let's sum our forces in the x and y direction, starting with the x direction. try to be consistent in what you do. So I tend to always start in the x direction. Okay, in the x direction, I have this negative, and I'm actually going to go right to the equation now. I'm skipping a step. We're doing a force diagram on our negative 3q charge. Okay. And the red, positive 2q, which is a distance L square root of 10 away, we're going to end up squaring that. And that is at an angle of cosine of 18.43. Okay. Now, in this case, we now have to add this vector to it, which is to the right. We're still doing a force diagram on our negative 3q charge, but the negative 1q charge electric field is pushing it to the left at a distance 3L away. Okay. Now multiplying this all out, I'm going to copy this negative down here. I see a 3q times k times 2q, so this is going to be 6kq squared all over L square root of 10. That's going to be 10L squared cosine of 18.43. Plus 3q times k times 1q. So that is going to be, I don't know why I wrote that absolute value. That is going to be 3kq squared all over 3L squared is going to be 9L squared. Okay. Going to go ahead and solve this here. So I'm going to factor out a kq squared over L squared. And then what we're going to have is, I believe we worked this out too on the other one, the red one, to be negative 5.69. So this 6/10 times cosine of 18.43 is going to be 0.589, right? I think that was it. 0.569. 69. Plus 3 over 9, which is going to be 1/3, which is 0.333. Okay, so this is going to work out to be 0.569 negative plus 0.333 equals negative 2.36. So this answer for this guy is going to be I'm going to do it again. I've already forgotten it. 569 negative plus 0.333 equals negative 0.236. So this is going to be negative 0.236 kq squared over L squared. But since we're rounding, so that's going to be negative 0.2 kq squared over L squared. Again, I only want you to put round to the nearest tenth. So negative 0.2. There you go. All right. Well, in the y direction, since we've done all the heavy lifting in the x direction, the y direction, again, just like the last problem, it's going to be just this. This is our hypotenuse, 6/10 kq squared over L squared. But this guy is pointing up, so I just wrote this. That's our hypotenuse. And then we have a sine of 18.43, which we've actually already worked this out in the last problem. When we worked that out, we got 0.189, which was 0.2. So positive 0.189 kq squared over L squared, which is positive 0.2 kq squared over L squared. So positive 0.2. All right. And that is your answers for the first two. All right. Let's do this last one right here. Now this is a triangle one, and it's a little bit easier than the other ones. Okay. So your one is also easier too. And you can get away with quite a bit here. Okay. So again, we are doing our force diagram, in this case on the negative 5q charge. You have a positive, red positive 3q charge up here and negative q charge over here. So first thing that we're going to do our coordinate system. And we're going to label our coordinate system. And negative y. Okay. Now, this red positive 3q charge is going to be pulling our negative 5q charge up towards it. And it's a distance L away. So this is going to be the force. It's not plus or minus. This is a hypotenuse. So it's positive 3q. And it's a distance L away, right there. The blue charge, the negative 1q charge, is going to be repelling our negative 5q charge to the right. So that's going to be a positive F negative 1q, and that is also a distance L away. All right, since we have a diagonal here, we have to break it into up and down and left and right. So since that vector is pointing up and to the left, so I'm going to write the addition of its two vectors right here. Again, if you're having a hard time with this, please watch the video, Addition of Vectors in Two Dimensions. All right, so we've got it. Now, can you guess what this angle is right here? You don't need to do any algebra if you don't have to. So this is an equilateral triangle, right? And if you add up all the internal angles, that should be added up to 180. Since we have 3 of those angles, you divide 180 by 3 and you get 60. So I want you to use whatever way you can to solve for this, right? If you had to solve for this, you could use this distance as the halfway point. This would be a half L. And this distance would be an L, so you have cosine of theta, which is going to be adjacent over hypotenuse, which would be the 1/2 L over hypotenuse, which is L. So you get cosine of theta, which is going to be equal to 1/2 L. Well, the L's will cancel out. So theta, and you take the inverse of that. So I just want to prove it to you. So 0.5, you take the inverse of that, and you get 60. Okay? So if you had to solve for it, I just took the right triangle to here. So I made this our right triangle, which this distance from here to the midpoint is 1/2 L. So that's how I got that. Or you could just say it's an equilateral triangle, so all angles have to be 60 degrees. Anyways, so this right here is going to be the hypotenuse, so the vector is pointing to the left. So it's going to be the hypotenuse, which is 3Q, positive 3QL, and it's going to be the cosine of 60 degrees. This upwards part is going to be the same hypotenuse, and it's going to be the sine of 60 degrees. Okay? So our angle that we're using is going to be 60 degrees right here. Okay, sum the forces in the x direction. Do the more difficult one first. It's got two vectors on it. So starting with this red vector, it's pointing to the left. And I'm going to go right to the equation here. So I'm going to write to the equation. So we have a negative 5Q that we're doing a force diagram on. The positive 3Q's electric field is acting on it. And it's a distance L away. And that's going to be the cosine of 60 degrees. I think the cosine of 60 degrees is 1/2, which we just found out. So since we found out this is 60 degrees, that's 1/2. So I'm just going to say this sucker goes to 1/2. Okay. Maximize my equation right there. And we have the positive equation right here, which is going to be our negative 5Q again. And that's going to be K, oops, I should be using blue. So K times a negative 1Q all over L squared away. So this red equation is going to be 5Q times K times 3Q. I'm getting 15KQ squared over L squared times 1/2 cosine of 60 degrees plus 5Q times K times 1Q. So it's going to be 5KQ squared all over L squared. Okay, I think I'm going to need some room, so I'm going to have to scooch all of this over. So now what I'm going to do is I'm going to pull out a KQ squared over L squared. And I'm going to have a negative 15 divided by 2. So what is that? 7.5 plus 5 So that's going to be equal to 7.5, negative 7.5 plus 5. So that's going to be a negative 2.5 kq squared over L squared. So a negative 2.5. All right, in our y direction, again, this is going to be much easier because we already have our hypotenuse right here. Okay, so first of all, it's going to be pointed up, but our hypotenuse is 15 kq squared over L squared. But we're going to be using the sine of 60 degrees. So that is going to be equal to whatever the sine of 60 degrees is. 60 sine 0.866. So this is going to be 15 times 0.866, which is 12.99. So 12.99 kq squared over L squared, which is just, oh, I forgot the plus, which is just 13. Which would be 13.0. All right. So this is your tutorials. This is the example tutorials for 1.2. Okay? So, and this is the Coulomb forces in 2 dimensions. Okay? I hope you have a great day, and I hope this helps you out a lot.